Okay, there's three parts to this question. First thing, this is a back titration. Almost every year they ask a back titration because it's a little bit more complicated than if you're doing a normal titration. Okay? Now, what you have to imagine is that you have two titrations occurring. One is actually related to the seashell. Now, this is it from the information in part B of the question. You also have information here for part A of the question. Okay? Now, if I'm looking at the information from part B just above it, it says that I have a titration occurring between hydrochloric acid and sodium hydroxide. Please note these equations do not have subscripts, so as a result, they're not right, but you would need to take that into account. Now, first thing here, you have sodium hydroxide. You need to calculate the concentration of sodium hydroxide. They've already told you the volume, and they have told you the specific concentration because that's been standardized. That then allows you to calculate the number of moles of sodium hydroxide. Now, because this is a 1:1 ratio, you can then figure out that that is the number of moles of hydrochloric acid that is remaining after the reaction with the seashell. Okay, so this is the number of moles final of HCl that's remaining in your solution after the reaction with a seashell. Next one down, this is looking at the information that was given to you in part A of the question. It was broken up into two sections. Now, they actually said that this hydrochloric was also standardized, and it was found out that its concentration and volume would work it out, and you have to work it out, to 0.0100 moles. That is the number of moles initially. Now, because you've got number of moles final, number of moles initial, to find out the number of moles that was actually used in this reaction, so actually used in the reaction with the seashell, you get the number of moles initial minus the number of moles final. And that will tell you HCl that's used. After this reaction itself, okay, you then have to look at the reaction with the seashell, because you need to figure out what sort of percentage of mass is used in both. Okay, now to do that, they haven't actually told you the metal ions in the reaction itself. Now you could imagine that this is calcium, hypothetically. Now this here is balanced, as we said, because they didn't put the metal ions in. We're just going to assume that they're floating in solution. Okay, now what you'll see here is that is exactly the same as this equation here, and that's how they got it. Now, regardless, this is going to be as 2:1 ratio, 2:1. So hydrochloric acid to carbonate. Now, we already know the amount of hydrochloric acid that was used in the reaction, and we know that that number is double the amount of carbonate that was used. As a result, divided by 2, that will get you a number of moles of carbonate. Now, because the equation is asking you for percentage mass, we're actually going to find mass. Now, there is a step here that is missing. You would actually have to calculate the molar mass as an individual step for carbonate. Now, you would have to also put in every single part of this reaction. So the fact that it goes 12.01 plus 3 times, and I would actually have to put my answer in there as well to the correct number of significant figures, because otherwise you are wrong. This is an assumption that you should not be making. Now that will get you grams. Now to get this to a percentage of mass, you have your grams that you've calculated. They've also told you the original mass of the seashell itself. To get that to a percentage, simply divide it times by 100. As we said, back titrations are asked every year, and it's all about reading the question.